Okay, guys, so the next section we're going to go over, we're going to talk about a little bit of direct variation and more about inverse variation. So for direct variation is an equation that is in this form. It has y equals ax, and a is a number. It could be any number. So they're giving you an example of y equals 3x. It could be 3, it could be 100, it could be decimal, could be 0.5 or a half, but the equation is going to be set up so it's always going to be x multiplied by some type of number. Okay, so it's y equals a will be some type of number, times x. That's direct variation. Now, inverse variation is the inverse of that. It's the flip of that. So it's going to be y equals a over x. So it's division instead of multiplication. X is going to go on the bottom of a fraction or ratio. And again, a is a number, so they're showing you an example here. Y equals 2 over x. And again, x is on the bottom. It is division. Okay? So they want us to, in the first type of problems, classify, say if it is or is not direct variation, inverse variation, or it could just be neither. It's not happening. So let's take a look at this example.
Tell whether x and y show direct variation, inverse variation, or neither. A. xy equals 5. B. y equals x minus 4. C. y divided by 2 equals x. Solution. First write the given equation, then rewrite the equation by solving it for y and identify the type of variation.
Okay, so if it's not solved for y, you want to solve it for y.
xy equals 5. The equation solved for y is y equals 5 divided by x.
Okay, so sorry, one more time. The first step in some of these, not all of these, but some of these, y is not by itself yet. So you're going to have to do that. So in this equation, to get y by itself, we would divide this side by x, divide this side by x. So the resulting equation would be y equals 5 over x. So think about those two forms that I just talked about 2 seconds ago. Does it look like either of those two forms? We said if it's direct, it's a number times x, and if it's if it's inverse, it's going to be a number divided by x.
So x and y show inverse variation. B. The given equation is y equals x minus 4. The equation is already solved for y, so rewrite y equals x minus 4. X and y show neither direct variation nor inverse variation. Study tip.
Oops, so sorry, in this problem, yeah, it's not multiplied by a number, it's not divided by x, it's actually added or subtracted, and that would be neither of the types that we're looking at right now.
The equation in part B does not show direct variation because y equals x minus 4 is not of the form y equals ax. C. The given equation is y divided by 2 equals x. The equation solved for y is y equals 2x. So x and y show direct variation.
Okay, so they didn't explain in this one, but again, we want to get y by itself. In order to get y by itself, we have to move this 2. So we would multiply both sides of the equation by 2. So this would be your resulting equation. And I just talked about earlier, if it's x times a number, that's going to be direct. Okay, so let's move on to the next type of problems that you're going to see. The next type of problems you're going to see is when they give you a set of data, a list of values for x and y, and you're going to have to decide whether it's direct, inverse, or neither for those. So when you're doing these problems, what you actually want to do is see if you have an a. So for direct variation, it's y equals ax. So if I want to see if a is if I have an A. And what I mean by I have an A, in these equations, A has to be consistent. It has to be the same number over and over and over again. So I'm actually going to rework this problem to get A by itself. So in order to get A by itself, I actually divide by X. So I have Y over X equals A. So if I take Y and I divide it by X and I keep getting the same number every time in these problems, then it's going to go ahead and be direct variation. Now, let's talk about inverse variation. In inverse variation, it's y equals a over x. Once again, we want to make sure that we have the same consistent a. So let's get a by itself in these. In order to get a by itself in these, we multiply both sides by x. So it's going to end up being x times y equals a. So I'm going to also check that. I'm going to go ahead and multiply x and y and see if I get the same number over and over and over again. If I do, then that's going to be inverse variation. So once again, we're going to try both things. We're going to divide y by x, see if we get the same number over and over again. If we do, it's direct. If we don't, it's not. And we're going to try multiplying x and y and seeing if we get the same number over and over and over again. If we do, it's inverse. If we don't, it's not. And if it doesn't happen to be either of those things, then it's going to be neither in these problems.
Tell whether x and y show direct variation, inverse variation, or neither. A. The values of x are 2, 4, 6, and 8, and the corresponding values of y are -12, -6, -4, and -3. B. The values of x are 1, 2, 3, and 4, and the corresponding values of y are 2, 4, 8, and 16. Solution. A. Find the products x, y, and ratios y divided by x.
So they're going to do those two things I talked about.
2 by -12
So they're
gives
multiplying these.
-24, and -12 divided by 2
And they're dividing
gives
these.
-6.
I would just do it across this way and then do this way, but
-6 gives -24.
so they multiplied these.
And -6 divided by 4 gives a -3/2. Multiplying
They
6
multiplied.
by -4 gives -24. And -4 divided by 6 gives a -2/3. Multiplying 8 by -3 gives -24. And -3 divided by 8 gives -3/8. Notice that the products are constant, but the ratios are not constant. So x and y show inverse variation. B. Find the products x, y, and ratios y divided by x.
So they're going to do it again. They do both at the same time. I personally just do one across and then one across me.
Gives 2. Multiplying 2 by 4
They're doing this one
gives
now.
8. And 4 divided by 2 gives 2. Multiplying 3 by 8 gives 24. And 8 divided by 3 gives 8/3. Multiplying 4 by 16 gives 64. And 16 divided by 4 gives 4. Notice that the products are not constant and the ratios are not constant. So x and y show neither direct nor inverse variation.
So that one would be neither because it didn't show any of the relationships. But if we wanted one that was going to show if it had direct variation, then we're going to have the same consistent number on the bottom here. Okay, so let's move on to the next example. Okay, so the next example is going to be writing an inverse variation equation.
The variables x and y vary inversely, and y equals 4 when x equals 3. Write an equation that relates x and y, then find y when x equals -2. Solution. First, write a general equation for inverse variation. Y equals a divided by x. Substitute 4 for y and 3 for x to get 4 equals a divided by 3. Multiply each side by 3 to get 12 equals a. Another way, because x and y vary inversely, you also know that the products x, y are constant. This product equals the constant of variation a. So you can quickly determine that A equals xy, which equals 3 times 4, which equals 12. So the inverse variation equation is y equals 12 divided by x. When x equals -2, y equals 12 divided by -2, or -6.
Okay, so what she's explaining is that if we're told we're going to write an inverse variation equation, we're going to start with the actual formula. So the formula is y equals a over x. We're going to take the numbers that they give us in the problem. So in the problem, they tell us y is 4, they tell us x is 3. We're going to plug it into the equation, and we're going to solve it for the unknown, which happens to be a here. That's going to be our constant. So we're going to go ahead and multiply both sides by 3 to get a by itself, which is 12. So now we can actually rewrite the equation with the number that we know a is. So we're going to rewrite the equation y equals 12 over x. That is the inverse equation. They're asking us to also use this equation to solve a second problem by finding what y is going to be when x is -2. So you take the answer that you came up with, the equation, you're going to plug in -2 for x, and then you're just going to do your calculations, and we have that y is -6. So it's just as simple as that. All right, last example.
The time t in hours that it takes a group of volunteers to build a playground varies inversely with the number n of volunteers. It takes a group of 10 volunteers 8 hours to build the playground. Make a table showing the time that it would take to build the playground when the number of volunteers is 15, 20, 25, and 30. What happens to the time it takes to build the playground as the number of volunteers increases? Solution. Step 1. Understand the problem. You are given a description of...
All right, I'm going to skip a little ahead here just so we can get to see the work.
So the inverse variation equation...
Maybe a little bit too far ahead. All right, so in the problem, they tell us that it varies inversely. Lucky enough. So we're going to do exactly what we were doing before. In this problem, they used t and n instead of x and y because it kind of referred to what they were using in the problem a little bit better for them. And so we're going to plug in the numbers 8 and 10. And we're going to solve just like we did the previous example. You're going to multiply both sides by 10, and you're going to get a is 80. So our inverse equation is going to be t equals 80 over n. Now we're going to use that equation in order to find the rest of the answers.
Divided by n. Make a table of values. Substituting 15 for n gives t equals 80 divided by 15, or 5 hours and 20 minutes. Substituting 20 for n gives t equals 80 divided by 20, or 4 hours. Substituting 25 for n gives t equals 80 divided by 25, or 3 hours and 12 minutes. Substituting 30 for n gives t equals 80 divided by 30, or 2 hours and 40 minutes. As the number of volunteers increases, the time it takes to build the playground decreases.
Right. And that's it, guys.
Looking for a pattern.
No, we're good. I believe that's all it asked us to do, so we're going to stop there.